going to use to find intervals of increase and decrease? The first derivative, okay? So why don't we go ahead and make ourselves a little sign line for the first derivative. Can you tell me the critical values for the first derivative? 0. Do we have any other critical values? Plus or minus 4. Remember, critical values are where the derivative is 0 or undefined. So if you have a fraction, you need to find those values where it's undefined. Before we just keep moving forward and following the same process we've done 100 times now, let's pause for a moment. Look at the original function. What type of function is that? No, not quadratic. Rational. What's special about rational functions? What do they have? Vertical asymptotes, we got horizontal asymptotes, maybe a slant asymptote. Okay, so you need to always, instead of just like starting and being like, let me just do all this process and like blindly follow whatever I've learned, you always need to look and say, okay, this is a rational function. I should know what this looks like. So what is happening at -4 and 4? Those are where the vertical asymptotes are. You might want to draw a little dotted line over those on your sign line, because that changes things a little bit. Can we have points on a vertical asymptote? No. So if you just blindly follow this and then you start like putting in pluses and minuses, you might accidentally think there's a relative max or min somewhere where there's not. So rational functions are kind of special cases here. All right, so intervals of increase, decrease. Let's start plugging in values. Let's plug in something smaller than -4, so maybe -5 into our derivative. So since this is a fraction, I'm kind of thinking, okay, what do we have on the top, positive or negative? Positive. What about on the bottom? Positive. Notice that squared. Doesn't matter what I plug in on the bottom, we're going to have positive. So positive over positive is positive. What about if I were to plug in like a -1? What would I get on the top? Positive, and I still am going to have positive on the bottom, so that's positive. What about if I plug in like +1? What am I going to get on the top? Negative over positive, so that's negative. What about if I plug in like 5? Same thing. Okay, so now can we do our intervals of increase, decrease? Where are we increasing? -infinity to, remember before, like on polynomials, we had like an x cubed, and we were like, even though at x equals 0, it goes positive, positive, just ignore the 0 and just go from -infinity to infinity. In this case, we need to exclude the -4 because there's a vertical asymptote there. So we are going to stop at -4, pick back up at -4, and go to 0. Okay, and what's my justification for this? Yes, f prime of x is greater than 0. Guys, on your quiz, you're going to get half the points for the interval, half the points for the justification. So everyone should make at least a 50, right? Because you will have memorized all the justifications. All right, where is it decreasing? Okay, because f prime of x is less than 0. All right, can we do any points of relative extrema? Do we have any? Yes. We have a relative max at 0. Relative max min and point of inflection are points you can see on the graph. So that means you're going to use f of x to get the y value. So what do we get when we plug in 0? Yep, -6 over 16. Sure, make it 3 over 8 if you want to. Okay, because f prime of x goes from positive to negative. Have fun. Anyone else going? It's a college visit. What college is it? Okay, and then for concavity, what are we going to look at? second derivative. Okay, so let's make another sine line. I guess I'll do it over here. Look at our second derivative. What are my critical values for this one? Well, I know two of them already, right? We still have -4 and 4 on there. And those are vertical asymptotes, so I'm going to draw my little dotted lines. All right, set the numerator equal to 0 and solve. What do you get? You can do it in your head. If you need to make a side problem to do it, then do it. But what would you get? What do you get when I set the numerator equal to 0? Square root of -4/3. What is a square root of a negative? That's imaginary, right? So we're never gonna do, if you get I, just stop doing the problem. So there are no other critical values. These are the only ones. All right, so now we just need to start plugging into the second derivative to fill out our sine line here. So if I plug in a -5 into this, might have to do a little bit of calculations here. Let's see, if I square it, that makes it a positive number, times a negative number minus a negative means I'll have negative times negative. So I'll have positive on the top. What about on the bottom? If I plugged in like -5, it'll be positive on the bottom. Okay, so positive here. Let's plug in 0. That might be a little easier for the middle section. Let's see, that would give me negative times negative on the top. So positive over negative, so that would be negative. And then what if we plugged in something bigger than 4, like let's say 5? What are we gonna get? Let's see. Yeah, notice how it's x squared. So even if I plugged in -5 or +5, you still get the same thing. So that's positive. All right, so where are we concave up? There we go. Because f double prime of x is greater than 0. Concave down from -4 to 4. Because f double prime of x is less than 0. Do we have any points of inflection? No, why not? I see it's changing concavity. Those are vertical asymptotes, so we can't have points of inflection where there's a vertical asymptote, okay? So please, I urge you, don't just start following the process and then being like, oh yeah, we got points of inflection, we got relative maximum, whatever. If there's vertical asymptotes, we can't have points there, okay? All right, we got one other warm-up question, and this is actually related to your homework for tonight. So it says the derivative, this should say f prime of x. I think it just didn't print out very clearly. So that should say f prime of x equals. On what intervals, if any, is the graph of f both decreasing and concave up? So when they're giving us both, they don't want you to say where is it decreasing and where is it concave up. I want to see where are they overlapping, where are they happening at the same time. So let's make a sine line for our first derivative. If I set my first derivative equal to 0, what are my critical values? Can you tell me one critical value? 3. Okay, because I know if I said x minus 3 equal to 0, 3. What about this e to the x equals 0? Can we solve that? If I plug in a 0 there, I get 1. No, that's impossible. If you took the natural log of both sides, we can't take the log of 0. So 3 is our only critical value. Ooh, I just noticed it says x is greater than 0. So you might want to put 0 on your sine line also and realize we don't want anything to the left of that. All right, so let's plug in some values. What if we plug in 1 into our first derivative? Will we get a positive or negative? Negative. What about 4? Positive. Okay, there where is f prime of x? When you're doing these ones that overlap, I like to do like a sign line, like one sign line for both of them. I'm gonna use a different color. Let's do red. Let's put f double prime of x on the bottom here. All right, so what rule am I gonna need to find the second derivative? I've got two things multiplied together, so I'm gonna need product rule. So what's the derivative of x minus 3? 1 times e to the x plus x minus 3 times the derivative of e to the x is e to the x. Alright, so we may be looking at this like I have no idea how I'm going to set this equal to 0 and solve. But see how we have an e to the x twice? Why don't we factor one out? E to the x, that would give me 1 plus x minus 3. Now I have e to the x times x minus 2. So what's my critical value for the second derivative? 2. Okay, so I'm going to put 2 right here. And now I'm going to put the pluses and minuses on the bottom of the sign line. So let's pick something between 0 and 2. How about 1? Will we get a positive or negative? Negative. Okay, let's pick something bigger than 2. What are we going to get? Positive. Okay, and you could put a plus here if you want to and here, because it's going to be everything bigger than 2. However you want to do this so it's kind of clear to you. So can we find where they overlap? Where is it decreasing and concave up? Right here, decrease. Oh, I thought I had a highlighter.
I thought it wasn't supposed to be less than 2.
It's not.
But negative 2.
No, that's minus for it's negative. I mean concave down.
Oh.
That's not negative 2, that's 2. So from 2 to 3. 2 to 3 because f prime of x is less than 0 and f double prime of x is greater than 0. So this is what the majority of your homework is for tonight. I am going to briefly talk about the second derivative test. It's super easy. You may see it come up on the AP exam like once, like maybe twice on multiple choice for the most part. But the second derivative test has nothing to do with concavity, actually. It is another way for us to find where there's a relative max or min. May not be used for much. You will be forced to use it at times. Okay, so I'm just going to draw a picture of the most basic relative max and min. We got a min here, a max here. What is true about both of those? What do they have in common? What? Yeah. But these points, like, do you know what the slope of those points are? Yeah, they both have a slope of 0. So if I knew that I had a slope of 0, and then I'm trying to figure out if it's a max or a min, this one's concave up and this one's concave down. So we can use our second derivative to figure out which one it is. Most of the time, to classify our relative max or min, we find the first derivative and say, oh, it goes from positive to negative or negative to positive. But this is like if they gave you a table of values, if they just give you a select number of points, this is what we're going to do. So here's how you do the second derivative test. If the first derivative is equal to 0, then I know I have one of these situations going on. It's one of those two. And f double prime of c is greater than 0. So what does that mean? Is it concave up or concave down? It's concave up, so that means I have a relative what? Minimum. So if f prime of c equals 0, okay, I know it's one of these two, and f double prime of c is less than 0, is that concave up or concave down? Down. That means it looks like this. That means I have a relative max. And And if we get 0 for the first and second derivative, then the second derivative test fails. You have to use the first derivative. If the first derivative is 0 and the second derivative is 0, at that point, I just think we don't have enough information to know exactly what's happening there. Alright, so I got 2 examples of this, and then I'll be done. Alright, so they're gonna give us 3 pieces of information here. We have f of 3 equals 7. That just means the point on the graph is at 3, 7. F prime of 3 equals 0. Okay, so if the first derivative is 0, I've narrowed it down to one of these 2 options. If the second derivative is negative 2, what does that mean? It's concave down for negative 2, so that means I have a relative max. Because, here's my justification, f prime of 3 equals 0, and f double prime of 3 is less than 0. Alright, so let's see if you can figure out the next one. F of 1 equals negative 6, f prime of 1 equals 0, f double prime of 1 equals 12. What is that going to give me? Is it a min or a max, or neither? This means it's one of these 2. This means it's concave up, so that's a relative min. And I would say because f prime of 1 equals 0 and f double prime of 1 is greater than 0. All right, and that is it for your notes for today.